Here we are, page 3 of the study guide. If Jake sold 42 chocolate bars and Larry sold 24 chocolate bars, what is the ratio in simplest form of the number of chocolate bars sold by Jake to the number of chocolate bars sold by Larry? So number Jake to number Larry. When you write a ratio, sometimes people write as colons, that's one way. So the number Jake sold was 42. The number Larry sold was 24. This is one way. Another way to do it is just write it as a fraction. So we do Jake to Larry. So 42 to 24. So that's also the ratio you can write. But of course, we can simplify this because I can divide both of these by 6. No, yeah, I can divide both by 6. 42 divided by 6 is 7. 24 divided by 6 is 4. And that can't be simplified. So the ratio of the number of chocolate bars sold by Jake to the number sold by Larry is 7 to 4, which means for every 4 that Larry sold, Jake sold 7. For every 7 Jake sold, Larry sold 4. That's my ratio, though. You go to the store to buy pens. Which package offers the best deal per pen? So one thing I could do is see I've got all these different amounts for different numbers of pens. So I could go and do this problem, $2.28 divided by 12. I could do $3.78 divided by 18. And I can do, or I could do it and then do $1.50 divided by 6. And that would work. Then I'd find out the cost for one pen. But I could also compare them by noticing in this case that, hey, 12 is just twice 6, or 6 is half of this, and 6 is 1/3 of this. So I could just simply, in this case, I can make this problem a lot easier on myself by doing $2.28 divided by 2. And then I would know how much this, I'll call this package A, I'll call this package B, and I'll call this package C. So 2 goes into $1.28 once. How many 2's can I get? A 4 or 8? I can get 4. So this problem here is the same thing as getting 6 pens, since I divided this by 12. This is the same, so this is A. I can get 6 pens for $1.14. Now all I need to do is check B. And if I want to match with 6, I have to divide this by 3, which means I have to divide this by 3. So I'm going to go $3.78 divided by 3. 3 goes into 3 once. The decimal point comes up. How many 3's go into 7? Well, 2. At this point, I can even stop. I don't have to finish it off because I can already see that this deal is going to be better. This is the same as $1.20 at least. So when I did 1 times 3 is 3. We'll go back here a step. That's the 0. Bring down the 7. How many 3's goes in 7? 2. 2 times 3 is 6. 7 minus 6 is 1. Bring down the 8. How many 3's go in 18? Well, 6. 3 times 6 is 18. 0. So, boom. So C, or actually this is B. Take it back. This is, so I can get 6 pens in package A for $1.14. For package B, I can get 6 pens for $1.26. And C, I get 6 pens for $1.50. So clearly A is the best deal. This right here. 12 pens for $2.28 is the cheapest per pen deal. A is cheapest per pen. Solve the proportion mentally. Now this problem is similar to dear, where'd the problem go? I'm sorry, forgive me here. I'm looking up an earlier problem that we did, and all of a sudden that piece of paper is... remember this problem here? Where, in this case, by simplifying this fraction right here, we were able to come and find out what value needs to go here, because we got this denominator to be the same. Here, similar kind of problem. What's going to make this proportional here? In this case, I could simplify here, or I could notice, hey, 5 times 6 is 30, which means 30 divided by 6 is 5. So if I divided this by 6, to get that, I have to divide this by 6. So 18 divided by 6 is 3. X is equal to 3. If the scale on a map says 1 inch equals 20 miles, then how long in real life is a border on the map? So I'm reading, so here's my map. Right, here's my map. And there's a border on it, and the border measures 6 inches. So I'm telling you, I'll make my map this big. Where's my map? And I've got this line on here, right? It's a border, and it's 6 inches long. The question is, so from here to here, it's 6 inches long. The question is, in real life, how long is that? Well, for every inch, there's 20 miles. That's what the scale is. So if I have 6 inches, I'm going to have 6 inches. And then for every inch, there's 20 miles. So I have inches that cancel out. 6 times 20 is 120 miles. Write a ratio equivalent to the ratio 13/9. So remember, a ratio is simply write as a fraction. So here's 13/9. We just got to come up with an equivalent ratio. Well, if I multiply both sides, top and bottom, by 2, 13 times 2 is 26 over 18. Of course, I can multiply it by 3 or 4 or 5. Just whatever I do has to be the same top and bottom. And I have an equivalent ratio. So write 0 and 74/100 as a percent. Remember, that's just taking a decimal number and multiplying it by 100. And multiplying by 100 is simply just moving the decimal point 2 places to the right. So if I move it 2 places to the right, I simply just go 1, 2, and 74/100 is the same thing as 74%. Write 73% as a decimal. Well, that's just going backwards. Remember, so I have to visualize that here's 73, and there's the decimal. It's going to go over once, twice to the left. So I have 0.73. And this should make sense because, remember, percent, this little sign here means out of 100. So this is literally 73 out of 100. And how do I say this fraction? I say 73 hundredths. 73 hundredths. That's what I say. Well, that is exactly how I say this decimal number. Which is, so being able to say the decimal number correctly helps me make a connection to how it's to be written as a fraction. In the case of hundredths, that's the one place value that we use as a percent. Find 60% of 72. There's a couple ways to do this. One way is 60% is the same thing as 60 hundredths or 6 tenths. So what's 6 tenths of 72? So I could write this, I'm going to write it this way just for sake of being able to do the multiplication. 6 times 0 is 0, 6 times 2 is 12, carry the 1. 6 times 7 is 42, plus 1 is 43. Now here's one place value in this number, and there's one place value in this number. So altogether I have 2 place values. So if here's my number, the decimal point is here to begin with because I don't have anything written down. I'm going to go over once, twice, so 43 and 2 tenths. 43 2/10 is 60% of 72. So that's my answer. What percent of 355 is 71? So one way to do this is to ask 71 of 355. So this is 71 divided by 355. So we have 355 going into 71. Well, I can't get 305 into 771, so I'm going to have to add a 0. I have to add a decimal point and add a 0. And think, how many 355s can I get out of 710? 2, so I can't get any, I get 0 out of 7, 0, 71. Decimal point comes up. How many 355s can you get out of 710? I'm going to try 2. 2 looks close. So 355 times 2, 2 times 5 is 10, carry the 1. 2 times 5 is 10 plus 1 is 11, carry the 1. 3 times 2 is 6. Look at that. It wasn't that convenient. So what percent of 355 is 71? So I have 2. This is my decimal number, but it's asking what percent, right? So 0 and 2/10. This is the problem I did before. I moved the decimal point over twice, once, twice, and I have to fill in with zeros. So 20%. So 71 is 20% of 355. Find the area of the parallelogram. Remember, the area for a parallelogram is equal to the base times the height, where the base are the two sides that are parallel. The height is the vertical distance between those two lines. So this is not the height. Not height. This is my height. So if that's the case, I have 30 inches times 20 inches. So I have 30 times 20 times inches times inches. I'm paying attention that I'm multiplying these as well. So 30 times 20 is 600. Inches times inches is inches squared. And that makes sense because we're asked to find area. Remember, area is always a square measure. In this case, I'm measuring in inches squared. So the area is 600 inches squared.